Hello and welcome back to another video with Liah. Today I'm going to be talking about quantum numbers. So in this video I'm going to be talking about their backgrounds for each, then we're going to go through some practice problems, then I will leave you with some questions to review and check your progress on this topic. If you're new here, my name is Liah, and on my channel you can find science and math tutorials. Now quantum numbers are useful because they are helpful in describing the properties of electrons and atoms. They can help us understand the movement of electrons, the trajectories, and the energy levels. Okay, so let's start out with the principal quantum number. Now this is going to be symbolized by n, and the allowed values are 1, 2, 3, up to n, right? So you just keep going on with positive integers. And what n tells us is about the energy level of electrons. And so that means that these electrons can move from different energy levels. When they jump to higher energy levels, that is called exciting an electron, and electrons lose energy when they go down in value. Okay, so higher n values equals higher energy, and lower n values equals lower energy. It is important to note that the allowed values for n start at 1 and then go up. They cannot be 0 and they cannot be negative numbers. Alright, so what does the second quantum number tell us? Called the angular momentum quantum. Alright, so first we have its symbol, which is going to be L. Now for allowed values of 0, 1, 2, etc., up to the value of n minus 1. And so allowed values of L depend on knowing the principal quantum number value. Okay, because the maximum L that you can have is n minus 1, so 1 less than your n value. Alright, and L can tell us the shape, okay? Can tell us the shape of the orbital. And how you know that is by using this key, by corresponding the numbers with letters. So numbers 0, 1, 2, and 3, these are going to match up with S, P, D, and F orbitals. Alright, so the shape of an S orbital is a sphere, a P orbital is 2 lobes, a d orbital is 4 lobes, and so on. And as you go higher and higher with these numbers, your orbitals get more complicated in shape. Usually, the questions on shape focus on the s and p orbitals. Now let's talk about the third quantum number, the magnetic quantum number. This is going to be shown by the symbol m's of L. Alright, and allowed values for m's of L are negative L values to 0 up to the positive L value. Alright, so as you can see, the third quantum number will depend on the second quantum number. Now, what does the third quantum number tell us? Well, it tells us the number of orbitals, and this is really useful for finding electron configuration. Then we have the fourth quantum number, which is the spin quantum number. Alright, and this is going to be symbolized by m's of S. Okay, and allowed values are only 2 of them. There's 1/2 and there's negative 1/2. Okay, so an electron can either have an upward spin or a downward spin, corresponding with positive or negative 1/2 respectively. Alright, and so basically what the fourth quantum number is telling us is the direction in which the electron is spinning, either up or down. Now that we have covered the 4 quantum numbers, let us jump into some practice problems. First question is as follows. So if n equals 3, how many orbitals correspond to this value? Okay, so remember, the orbitals is dealing with the m's of L value, alright, and we have an n value. So what you want to do to this is to go from the n value of 3 and then find what L values you have, and then finally figure out what m's of L values are and count up how many values that is in order to find your number of orbitals. So starting out with finding your L values, well, we know that we have 0, 1, and 2. We can only go up to 2 because n minus 1 is going to be 3 minus 1, which is 2. Alright, so we know that we have to include 0, 1, and up to n minus 1, which is 2. So now our L values are 0, 1, and 2, and then we're going to find our m's of L values. So remember, m's of L values are going to go from negative L values to 0 to positive L values. We're going to have negative 2, negative 1, 0, 1, and 2. Alright, so you go from your minimum to your maximum value. And so if you count up the number of values this is, you have 1, 2, 3, 4, and 5. So in this case, you would have 5 orbitals. Alright, so let's try out the second. So if n equals 1, what are the values of L, m sub L, and m sub s? Alright, so now we have n equals 1. Okay, so let's go on and find our L values. So this is going to be 0, and that's it, because n minus 1 in this case is going to be 1 minus 1, which is 0. So 0 is the maximum L value that we can go up to. Let us find m sub L next. So remember, this is just going to be 0 because we don't have anything else for L. So that's the only thing we can write down for m sub L. The m sub s values only have 2 possible values, and that's going to be positive 1/2 and negative 1/2. So if m sub L is equal to negative 1, 0, and positive 1, what are the values of L, m sub s, and n? Alright, so here we're going to go backwards a little bit. Okay, so we know that m sub L equals negative 1, 0, and 1. Now, because there are only 2 possible values for m sub s, let's find this one. We know that's going to be positive 1/2 and negative 1/2. Now we're going to go backwards a little bit in order to find the L values. Okay, so how do you think we're going to do that? So it turns out that you're just going to take the positive parts and 0 as your L values, okay? And so we have 0 and 1 for L. Remember that L cannot be negative values. The lowest it can go is 0, and then upwards. And finally, for our value of n, okay, so now we're going to go from L to n. And so remember that the maximum value of L is n minus 1, right? And so if n minus 1 is equal to 1, then this must be 2. And so we know that n equals 2 in this case because we are given the maximum value of L, which tells us that that value was n minus 1, and so we just need to find n. Okay, so what minus 1 is going to be 1? Well, that's going to be 2. Okay, and so for our quantum numbers, we have the spin, the positive and negative 1/2. For L, we have 0 and 1, and for n, we have 2. If L is equal to 0, 1, 2, and 3, find the number of orbitals and electrons. Alright, so I will start this off by saying that each orbital of an electron can only hold a maximum of 2 electrons. So orbitals can have 1 electron, or they can have none, but the maximum they can go is 2 electrons. Okay, so we know that L is equal to 0, 1, and 2, and 3. So dealing with orbitals, right, we know that we are going to have to find the m sub L value eventually. So the first step I would do for this question is to find the m sub L values. Okay, so we have the negative L values, 0, and the positive L values. So m sub L values are going to be the positive part here that we see, and also the negative part. So negative 3, negative 2, negative 1, up to 0, and then positive numbers. So 1, 2, and 3. Okay, and so if we count this up, we see 7 orbitals. Okay, so I will put that as a note here. Now, to find the maximum number of electrons that could potentially go into these 7 orbitals, all you need to do is multiply 7 times 2 to get 14. And this will be your number of electrons that are possible. So it's your maximum number of electrons that can go into these orbitals. Now try this one on your own. Give the shapes of angular momentum values of 0, 1, 2, and 3. In the next question, we have an electron that has the following values. We have the n value equal to 2, we have L equal to 0, we have m sub L equal to 0, and m sub s equals positive 1/2. Okay, so remember this electron is in an orbital. Okay, and then what are the quantum numbers for the other electron in that same orbit? This is an important point because this reminds us that 2 electrons in the same orbital can never have the exact same quantum numbers. Something has to be different. We know that its energy must be 2. We know that for the second electron, L is going to be 0. We also know that m sub L is going to be 0. And then the only thing that can be different is the m sub s value. Okay, because they're in the same orbital. And so they need to have these same 3 first numbers. The only thing that can be different now is the spin quantum number, and that is going to be -1/2 for the second electron. Now it's time for you to check your progress on this topic. So I've given you 3 questions here that you can feel free to answer in the comments, and feel free to comment on other people's answers and discuss this. If you didn't already know, I published my first book. It is a productivity tracker for students, and it lists nice sections to organize your day for 1 month. Alright, so if you want to go and buy it, I'll leave the link in the description box below. That same link will lead you to my website, my Instagram, and other resources for science and tutoring. Alright guys, I'll see you next time.